Hi guys, today's problem is task C of ABC 257. The input is N, S, and W i's. N is the number of people. S is a 01 string, meaning each person is an adult or child. For example, the first 0 means the first person is a child. The next one means the second person is an adult, and so on. Like like this. Uh, each WI's is the weight of the person. So the first one has 40, and then the second person's weight is 33, and so on. Then we choose any real number x and count the number of adults whose weight is greater than or equal to x, and children whose weight is less than x. We count them, and then the output is its possible maximal number of the counting. But note that you don't need to print x. So this is a problem. So let's think of it with the example. If we take x as 50, then we count the first one because he is a child and his weight is 40, which is less than 50. But we don't count the second one because he is an adult and his weight is 33, which is not greater than or equal to 50. The third one is a child and he has 50, but it fails because the border of 50 is for adults. So keep going on. The result is 3. Like this, you can do other cases. You may guess the answer is this example's answer is 4, but we should consider more cases. So I hope you comprehend the problem. So let's talk about the solution. First, it's better to sort it in order. And then you may find out how to make borders. I mean, x is 21 or 22 or 23 is the same. So you should pick out only one number between 20 and 33, and we and then we don't need repeated 40. So the next step is to cut out repeated numbers. Then we have a list, and then we should choose borders from each gap. Each gap. First we get 0, and then we get 26, 36, and so on. So any number between them is okay, but I take the number uh, to thinking about the quotient of the sum divided 2. This is almost always good, but you have to pay attention to successive numbers like 70 and 71. In this case, the quotient is 70. It's not so good. So, uh, so in this case, I adapt 70.5 instead of 70. So finally, we we get all the borders here. So all we have to do is try them one by one. So I tell you how to check it and how to count the number. First, we divide the list into children and adult like this. Then sort them in order. If the border is 26 for instance, it is between 20 and 40 in the children's list. The useful tool is bisect in Python. You can write it like this. This function means you get the minimal index whose value in the list is greater than 26. In this case, we get 1, and 1 is the number of children whose weight is less than 26. So the number is 1. Then we adapt it for the adults list. Again, we have 1 using bisect. And the number of adults whose weight is greater than or equal to 26 is the length of the adult list minus 1, which is 2. Therefore, we get 3 when border B is 26. So repeat this process for every border and retaining the maximal result, and the result is the answer. That's all about task C. My code is the description. Thanks for watching.